Example 4, we have the absolute, all right, something is wrong here. It should be absolute value of 5x greater than 7. All right, so that's our example there. Absolute value of 5x greater than 7. Going back to our first property, to our properties, we can make use of property number 2. Absolute value of x greater than a. Right? It's greater, so we'll be using this. We can rewrite it into x less than negative a or x greater than a. So using that property, we now have here 5x less than negative 7 or 5x greater than 7. Dividing both members of the inequality here by 5, you have 5, x less than negative 7 over 5. What's negative 7 over 5? In mixed number, that would be negative 1 and 2 fifths. Same thing here, divide by 5, divide by 5. X will be greater than positive 1 and 2 fifths. Or we put order, so our first, the solution is x less than negative 1 over 2 fifths or x greater than 1 and 2 fifths. We can also write the solution in a graph. We can show that in a graph. So we have negative 1 and 2 fifths. The other one is positive 1 and 2 fifths. For x less than negative 1 and 2 fifths, is it open at negative 1 and 2 fifths or closed? Will be open, and then less than negative 1 and 2 fifths is are all numbers less than. So they are all at the left. How about 1 and 2 fifths? Is it open or closed? It's going to be open, and all numbers greater than 1 and 2 are to the right of that number. So we have that graph. We have two rays in our graph, and we can represent this into interval notation. So what's our interval notation here? Let's first have the left one. The ray that goes to the left. Okay, that's negative. Negative infinity, arrow to the left is negative infinity to negative 1 and 2 fifths. What shall we use to enclose this? Parentheses or bracket. It's gonna be parentheses and then or. So or is like this. Parentheses. Now the left that goes to the right. Okay, it's positive 1 and 2 fifths. It's parentheses. And then arrow to the right. Positive infinity, arrow to the right, and then parentheses. Always use parentheses for infinities. All right, so we have here arrow to the left, negative infinity, and then the right member is negative 1 and 2 fifths. And then for the right way, 1 and 2 fifths, then arrow to the right is positive infinity. So you always have to look at your graph so that you'll know where's the right placement for your, or the right place for your infinities. Infinity here first, and then here infinity, negative, positive infinity is the last one. For example 5, you have the absolute value of 2x minus 12 greater than 24. No numbers outside the absolute value, so we are free to use the property. Property number 2, greater. All right, so we can write this as 2x minus 12 less than negative 24, or 2x minus 12 greater than positive 24. So less than is for the negative and greater for the positive. Let's solve for x in each. We have to get rid of negative 12 first, so that's plus 12 plus 12. And now this is 2x less than -12. Divide both members by 2. Your x is less than -6. Right side, I mean the other one. 2x minus 12 greater than 24. This is plus 12 plus 12. The result will be 2x greater than 36. Divide both sides by 2. X is greater than 18. Right? We put or here. That's the solution of our inequality. We can also represent this into a graph. So let's say this is our line. We have -6, +18. So x less than -6. At -6, is it open? Or it's open at -6. All numbers less than -6 are those numbers to the left. So we can show that using that ray that goes to the left. And for x greater than 18, it's open at 18. All numbers greater than 18 are to the right. So we have this graph that shows our solution. How about our interval here? Okay, there are two rates. So what's how we put here? Negative, arrow to the left, -infinity to -6, open. So we use parentheses. Or this is 18 to +infinity because we have an arrow to the right. So that's our solution set for example 5. Absolute value of -1 minus 2x greater than 5. Okay, so here's another inequality.